Hello guys, welcome back to day number 17. So today we're gonna do this one priority encoder. If you have already done from your side, that's a great thing. And for people who haven't done it, let me help you. If you don't know what is encoder or priority encoder, then also you can just go through this lecture because we are learning Verilog, right? We are not learning our digital electronics. But if you want to know more about priority encoder, then you can refer to this tutorial. Not tutorial but blog, you can say. Here they have nicely explained what does priority encoder means. From there you can also revise your decoder basics, simple encoder basics. But here what we are doing, or what's the actual application in industry, like why we use encoder. A simple example would be your keyboard, right? So anytime you just press 2 of the key, then your computer, your processor need to decide which input it should take, right? So there we need to define the priority, and that's where this priority encoder is used. For example, in this example, they have given this as a input, so you can consider it as a 8 input. Like for example, in your CPU you have mouse, you have keyboard, you have pen, and there are many other things. So likewise we have 8 input. You probably USB, USB-C, USB-A, those are there, right? So you have provided all the input, this 8 different type of input to your CPU. Now your CPU can accept only one at a time, so that time and here 0 imply that input is not given, and 1 imply that here that is high. I need to take or I need to accept the input from that device or that interface, right? So here you can see 2 things are 1. So we need to tell, or we need to give some algorithm to our processor that here you can take this one and you can ignore other one. So here the main priority encoder is used. And in this example which they have given here, what they are doing the priority based on the first one. So for example, let me take, this is probably your mouse, right? And likewise you have many input, and this is probably your pen input, like this. And then this is probably something attached to your USB-C port. So now from USB-C port something is coming, and from your pen also something is coming. Then I will only accept my pen, or the first one I am getting. So here the first one is at the 4th position. So this input here at the 4th position, I have the input, so I will only accept the 4th and I'll ignore the other. These information are good, but again these information are not required to learn Verilog. So here what's the task we have, and for sure we're gonna use the case statement which we have learned in our previous video. But in this video we also gonna know a new feature of case which is not present in any ordinary programming languages. So it's important, like it will give you another differentiation between Verilog and the conventional coding. So let us first do the simple example which they have given to us. So here what we need to do, we need to build a 4-bit priority encoder. For 4-bit priority encoder means, see, you will have like this. 4-bit means you will probably have 4 type of input, and let's consider this is our CPU, right? And not actually CPU, this would be your interface, right? And this interface will give here, if I have 4 type of input, then how many combination I can have? I can have 16 type of combinations, right? But in my output, if I want to tell, here your CPU is sitting, this is your CPU, and this interface will talk with CPU. Okay, so now if I want to tell my CPU that which input location gone high, then how many bits I require here. So I have 4 position, so to tell the 4 position in binary sense, I need to have 2 bits, right? Because 2 bit can accommodate the 4 combinations. So here at the output I need to have 2 bit. So probably if this fellow or this position went high, then I will give my CPU information that hey, something at 00 location is high, please take the input from that. Okay, this is the work of encoder, not the work of priority encoder, but the work of encoder. And if something is high at this location, then I will give 1 and 1 signal to my CPU that hey, something at location number 3rd, or in here 4 you can say 0 1 2 3, but yeah, it's third or fourth, no issue. So at location number third, because we are starting from 0, so that's why third, don't be confused. So this is the work of encoder. But in priority encoder, what will happen if this is also 1, this is also 1, then what should I accept? So that's the main condition. And according to here what we are designing, and that is anytime the 1 appear the first time, we will take that as our input. So for this example, if your 1 in the first position, then other two input are 0 0, then another 1, then at the output here we will only give this, like at 0 0 you have some input, please accept it, and we will ignore all other thing. So that's our task here, very simple. So let us do it. So here you see you have input are 4-bit, because we have 4 input devices or anything we have, and then to tell our CPU we need 2 output to tell the location. So that's why here 2 bits, right? So here what we'll do, we will write simple, and that is we will write case statement, and inside case what is the control statement? This in actually, right? So we'll take in as our control statement, and then we will keep on writing. Now there we need to know one thing, we have 16 combinations, right? So for example, let me write first one. I will write here like this, 4-bit binary. If it is 0 0 0, then which position to take? 0 0 0, nothing is there, so our position would be assigned to 0. That's simple. Now 4-bit binary 0 0, 4-bit, 4-bit 0 0 1. Here I done something wrong. Yeah. So which position I'll tell to my CPU? I'll tell that at position number 1 something gone high. So I will write, I can't write directly 1, right? I need to specify which type of number system I'm using. So if you are using binary number system, then you need to write 2-bit, then this, then B, and then 0 1, right? Now we'll have a confusion, and the priority encoder will take place, and that is if you have this input, for example 1 1. So that time what gonna you do? Because 2 input are simultaneously 1. So that time we will take the priority encoder privilege, and we will tell that hey, only at 0 0 position something is up, please take it up. So I'll write pause equal to 0 directly, or I can write in binary fashions also, 2-bit binary. Okay, but see, likewise we need to write 16 line here, right? 16 lines here, and also if you gonna write in binary, then it's like 0 0 0, it's too much of work. I have some way by which we can reduce the 16 line into 4 or 5 lines probably, but for now I'll write the 16 line, but let me do it in probably in decimal sense. So in decimal if I write, then I just need to write like this, 0 D and then 0, then here I'll write D decimal format and directly 1. So you are getting the benefit, right? So here I have specified all the combination, all the 16 combination. It is a little cumbersome, but for we are starting, we need to write 16 line, but we have some shortcut, I'll tell you. So here I think everything is clean and clear. For example, let us take this this example. So here what is happening, your 7. So in binary, how you gonna denote your 7? And that is, it is 0 1 1 1. This is your 7. This is your 7, right? So now tell me, your out of 4 input, 3 input are high. So which one we gonna take as a priority encoder? We gonna only take first one. So that's why at the position C, I am giving it's a position 0. Ignore the other. Let's take example for this one, 14. So how you gonna write 14? Okay, your 14 is this one, I guess, if I'm correct. Okay, so if this is your 14, then see, you have 3 things are high, but we will take this fellow, this location, and this location is at 1th location. So that's why I am here giving D1 in decimal sense, the 1th locations. So I hope you don't have any confusion here. So let me execute it and see if we have a result. And see, we got a success, and that's perfect. You please go through this thing to explain yourself what is happening. I'm not going through again here. Okay, now is the time to reduce this hard work. How to do that? So to reduce it, you need to know a special feature of your case, and that is you have your case, but also we have something called, and that is case Z and case x. These two things are exclusive to Verilog, not in any other programming language. So case z, what it will do, it will take care of z. Like anytime z is coming, z means your high impedance. In our initial classes I said, right, Verilog we have 0, 1, z and x. So for example, some input you got like this 4 z 1 0. So that time what to do? So to incorporate this z as a condition to our case statement, we use case z. So z is considered as don't care, and case x would do the same thing, but it will take x or z as don't care. Things will be clear when I'll do the same example using case z. And why I am doing, I can reduce my step actually. So let's do it. So I will write, now I'll go for binary system only because I want to incorporate z. So I need to see each bit, right? So I'll take 4 in the binary and I'll write z, z, z and 1. So if you get this, then which one I need to select? Because see, why I can tell, like I can take these things as z, z, because anyway we are not caring about this thing. If we have 1, 1, 1, 4, 1, then we are just caring nothing about other 3, 1. We are just taking the first one and getting the output, which is the 0th location. So why to write all the combinations? So that's why I am doing this. Okay, and here it will be, you need to change it to case z. Okay, so if it is this, then our pause will equal to 0. At 0th position I have my input as high. So let me copy it. How many time? Only 4 time, I guess. Okay, so now if it is z and 1, then your position would be 2-bit binary 0 1. Don't get confused here, because 0 can be 0 is 0 in all the number systems, so that's why I'm not defining what's here. But if you are still confused, then I can write it like this. It's all okay. 0 0. Okay, now let us submit and we must be getting a answer, success. Let's see. We're getting some warning. Okay, Verilog warning. Okay, case x and case z we are using those. They are just giving us a hands up that hey, we got a wrong thing. Why we are getting a wrong thing? Something we must have done. Yeah. So to identify what I am doing wrong, see here I am getting a mismatch, and I am getting a mismatch for a input of 0. Okay. Oh, I haven't defined here what will happen if 0 is there. So if it is 0, or I can directly write default, right? We know that we can use default statements. So otherwise, if everything is 0, then your pause would become 2-bit 0 0. Now I think we'll get a and see, we get a success. Okay, but this have some issue. For example, if I take input as 1 1 1 4 1, right? So see, if you take this as an input, this is also satisfied because other are do not care. This is also, this is also, this is also, all 4 are satisfied, right? But as we have written this thing first, this fellow first, our case statement will select this and it will ignore all other combinations, right? So that's why if we do something like this, if we just change the order of our case, then we will be in big trouble. Because for now, if I give input as 1 1 1 1, then see what will happen. Because all the 4 case statements are true here, it will take the first one and it will give input as hey, at your second position you have a 1. But according to our algorithm, we need to select the first position 1, right? But this is not happening. So that's why if you do like this, you need to be dependent on how you are defining respectively your case statement or case options. So that's a rigidness of using like this, but you can just correct it. And correcting how, you just need to add these fellows. Don't put everything as don't care and only one as don't care, but like this. So now see what is happening. Now if you put anything up down, there is no issue. For example, if I again give a input as 1 1 1, Now see, this input is not matching with yeah, it is matching with this for sure, but it is not matching with this because one item is 0. It's not matching with this, it's not matching with this, right? So now if I just mistakenly I have defined it at the end, then also my output would be perfectly fine. So let me submit it and see, we got a success message. And just for the curious people, let me try out this one quickly, that here really it is not working. If you use ZZ and if you shuffle your order, then your case will break down, you will get a wrong answer. Let's see. So that's why anytime you are using Z, don't care, you need to be little careful. And see, we got a red mark, so we are getting a wrong answer. So I hope this exercise have given you a more depth into how case X, case Z are being used. Case X we haven't used here, but yeah, case X and case Z are similarly, they are working. Case Z will take consider of high impedance and X will take consider of both the thing. Another thing you need to remember here, and that is Z can also be given like this. It's also perfectly true, right? It's also work. So you can, if we any example you find like this, don't be confused. Question mark imply Z only. So in our next problem, actually what they are telling us to do, and that is you need to build a 8-bit input encoder. So 8 means 256 combinations. So that means if we don't have case X, case Z kind of thing, only case, then we need to write 256 lines of code. We are lucky we have case X and case Z. Using case X and case Z will become only 8 or 9 lines of code, right? So this is for sure it's a homework for you. I will never gonna do it because it's same as the previous question. So now is the time for today's question, and this is your today's question, right? You need to predict the output of this small Verilog code. Here something would be unknown to you, and that is monitor. So monitor is something like it will keep on printing your value, like it's a print statement in other conventional coding system, but the difference is that it will keep on print like executing it anytime the variable gonna change. So what are the variable we are using here? We are using a time, which is predefined variable, and then a and b. So anytime this variable value gonna change, this monitor will be called for sure. Don't get confused that hey, it is initial, so it will run only once. It will run only once, but this monitor will keep on running anytime those variables gonna change. So it's a very good example to demonstrate you know about blocking and non-blocking statements. So please give it a try, and we will discuss in depth about this in our day number 18. Till then, tata, bye bye, keep smiling.